and we will get started from here. All right, thank you everybody for joining. This is the return of the Chess virtual user town halls. This is something we haven't done in a couple of years, but it's something we would like to get back to on a recurring basis. We're hoping at least twice a year, and then going forward from there. So just a quick agenda for today's meeting. We're going to start with an introduction from Joel Brock, our chess director, then move on to an operations update from Katie Morin, our X-ray operations director, then some chess user office updates and announcements from myself, Chris Mobley, the user office manager, then some checks, Mac Chess, HMF updates from Jacob Ruff, our checks director, an MSNC update from Arthur, our MSNC director, and XLeap update from Ernie Fonts, our class technical director. And we also want to provide this as an opportunity for our user community here to engage with us. So please feel free to put any questions in the chat or speak up if you would like, and we will do our best to engage and answer any questions that are coming up during these updates. But from there, I will leave this over to Joel.
Thank you, Chris. So welcome everybody to the town hall. And I guess I just have a couple key messages. The first one is welcome. It's great I wish I could see you all. In the wonders of Zoom. I hope everything's working for you. And I just a couple key messages that these will be reiterated by many people. And I don't want to take away everybody's thunder. But the key message I want everybody to have is, despite the rapid changes in Washington, D.C., and everything you read in the news, chess continues to thrive, and things are really going very well here. And just a couple quick highlights. Jacob will give you a lot more details about this, but the short story is that the Caesar and the accelerator have been running extremely well. The accelerator physicists have created new operating modes for us, which we've been able to deliver, longer lifetimes and or timing modes. Our usage levels during the dark period for APS and SSRL at the same time, our oversubscription got quite high, and it's returning to pre-dark time levels. So we're still oversubscribed, but now close to factor 1.5 or 2 rather than 4 to 8, right? And that's a huge difference. And we're in the middle of our spring down and looking forward to another the 2026 2 run. Come back and we'll be getting back to our standard operating pattern. Also, as I think everybody knows, Chess has been involved in 2 mid-scale research infrastructure for construction projects, and you're going to hear about those from Jacob and Ernie. The short answer is they're both going extraordinarily well. The high magnetic field beamline project, the X-ray part, the beamline is done, and we're awaiting delivery of the 20 Tesla magnet hoping that will be delivered this summer and installed, ready to take beam in the fall. And the other project is actually, it's on time and on budget, and you're going to hear a lot more about that, I'm sure, later on. And it's no secret, but we have multiple proposals pending at just about every funding agency you can imagine, and those are actually going pretty well. I'm optimistic that by the next town hall, we'll be bragging about some new awards, but I don't want to count any chickens too soon. So with that, I think I should get out of the way and let people who have pretty pictures and a lot more to brag about go on. Unless people have questions, I'd be glad to take questions now or at the end. Hearing no questions, let me get out of the way.
All righty. Thank you very much, Joel. I think we can turn things over to Katie.
Sure. Hi, everybody. Just a few quick updates. So we've got some new faces in the lab. We've got 4 new chess operators who have started recently: Kim Crossan, Patrick Hollister, Ash Johnson, and Will Reed. So if you're on site for the next run, expect to see these folks around helping out. And just an update on the run schedule. If you were here for last run, you may have noticed we had a reduced running schedule, but we will be returning to our normal 24/7 operation schedule for the spring run. So Beam will be available for users from noon on Wednesdays to 7 a.m. on Tuesdays, and there will be chess operators on shift 24/7 for the next run. And that's all from me.
All righty. Thank you, Katie. I'll take over for a little bit. Just a few announcements from the Chess user office on a couple of different things, but we'll start here with a new feature within BeamPass, BTR change requests. This rolled out and was put into use for the first time during our 26-1 winter run, this past run cycle. But this is really a change where all desired changes to a beam time request experimental materials will now need to be submitted using the new BTR change request option available in BeamPass. So just to be a little bit more specific, this is going to be used for adding or changing samples for your group's experiment or potentially incorporating new equipment into an experiment. And just to be clear, these are expected to be submitted on all hazardous and non-hazardous beam times alike. This would not be used for changing requested experiment dates or adding users or collaborators to the experiment. That would still be done through the normal communication pathways that you're used to with either your Beamline scientist or the Chess user office. Then just to illustrate what that's actually going to look like, in BeamPass, when you're on your BTR page, right in the top right, you'll see this new option here to submit a change request. And then when you hit that button, this is the window that you'll actually see to provide the details for your group's requested change. We have more information on a new BeamPass feature webpage on our Chess website. That's actually linked at every user's top of the homepage on BeamPass. There's a text box referring to the BTR change request, and there's a web page directly linked there, which will also be provided alongside this recording on the Chess website as well. Also want to pass on a few messages from our safety committee. They just want to update and flag a few things, mostly regarding our proposal submissions to our user base. First thing that they're requesting is please make sure your key information is provided directly into the BeamPass proposal itself. So please only provide what would be supplemental information within your PDF attachments as much as possible. So things such as sample lists, equipment, and general procedure should all be written directly into the relevant fields/sections of the BeamPass proposal. They'd also like to request to include an SDS in your proposal for all chemical items that will be brought to Chess. So for novel synthesized materials in your lab, please attach a relevant SDS. Just breeze right into the next one. This is a separate item for making sure for novel synthesized materials in your lab, please attach a relevant SDS for a similar commercially available product. So to be more specific, for a novel mesoporous silica structure, please submit a commercially available mesoporous silica SDS with similar properties like pore size, distribution, or density. Also want to give a quick shout out to some dates and deadlines for upcoming run cycles. For the 26-2 spring run cycle, rapid access submissions are open. That would be for our MSNC and Mac Chess beam lines. The run cycle dates are April 29th through June 30th. And the 26-3 fall run cycle, the proposal submission window will be opening up June 3rd and closing July 15th. The BTR submission window will also open up June 3rd and close July 29th. The run cycle dates for that are the September 23rd through November 24th. And just a quick plug for this year's user meeting. The 2026 Chess user meeting will be virtually held on June 2nd, 2026. This year's theme is Accelerating Innovation, where we're really going to try to highlight Chess's unique position within the greater light source community. There will be organizational and program updates, user talks, a virtual poster session, and more. We will have a physical viewing option available at the Physical Sciences Building at Cornell, but no meals, refreshments, or materials will be provided to the in-person audience members this year, unfortunately. And that's it from me. So I'm going to turn things over to Jacob, our checks director. Thank you.
Thanks, Chris. Next slide, please. Okay, so Joel led this off, but the first thing I'd like to say as I talk a little bit about what's going on with our user program is to take a moment to say thank you and acknowledge the work of our accelerator team. They really have been delivering outstanding performance from the synchrotron over the past year. 96.4% reliability averaged over the last 3 runs. That's the highest I can ever remember for a year. So that's really extraordinary. Even better, of course, is the fact that they did this while also running in several sort of unorthodox modes. So the bulk of this time was in our standard 9x5 bunch pattern, but we also ran in 13x1 and in 18x5. So we really are getting just outstanding performance out of the accelerator. Just want to take this opportunity to say thank you very much. I'm sure every one of our users appreciates it because the stability of the beam really enables all the science that we can do. Next slide, please. Okay, so the other thing that I'd like to talk about that I'm excited about is that after 5 years of very hard work by enormous numbers of people around the lab, the HMF beamline construction project is largely complete. Remember, this work started in January of 2021. It included construction of a new building, an entirely new greenfield beamline, and just a huge amount of design and engineering and construction work by a lot of people. So thank you all very much for that. It's a beautiful thing that you built. The last piece of the X-ray beamline was installed last month. That was the primary focusing mirror. We are still awaiting final delivery of the high field magnet, but it should be here in the summer. And we should be doing user operations later this year. So we are also accepting proposals, user proposals, for early experiments at HMF. Next slide, please. So that long, the slide I showed you before, this was an engineering drawing. This are 3D CAD. This is the way we've thought about the beamline for a long time. But now, of course, it's real. So this is just a smattering of images of actual stuff, mirror chambers, high-res mono, front end, mezzanine and hutch. So this thing really is done. It's in place, and it's an extraordinary amount of tech. Next slide, please. And of course, so what you're looking at on the right is the vacuum end station, which was installed last year, which will contain the high field magnet and the detector and really perform all the diffraction measurements. The thing on the left is the magnet. This is the last thing that's absent, but it does exist. So those are our custom superconducting coils in a test cryostat in the UK. So they're currently undergoing coil testing. But soon that thing will be assembled into its final cryostat, flipped on its side, shipped across the ocean, and dropped into the top of this vacuum end station. Then we can actually start to do science. So, next slide, please. All right, so speaking of the user program, which HMF will soon join, the chess user programs, the Chex and Mac Chess beamlines were very effective. Over the past year, the lab hosted more than 900 researchers. There's sort of a quick illustration of just looking at the sort of North American users where they came from. Of course, we also had users from Europe and Asia. And just to remind you of, who are we doing all this for? About 40% of our users are grad students, about 15% are postdocs. So that's more than half of our researchers are really early career. So we remain, a teaching synchrotron, and that's fantastic for us. About 26% of our users are Cornellians. So that's folks who are at Cornell. And of course, that means the other 74% are from everywhere else. So that's the user program remains really robust. Next slide, please. And also very productive. So I'd say that looking at these open user beamlines, we see more than 400 papers acknowledging the support of those awards. And they've been published in really extraordinary journals. They've been cited more than 8,000 times. So this is really significant impact that we're having in the research literature. So great work, and congratulations to all the chess users. The work that you're doing is really being noticed by the world. Okay, next slide, please. Of course, there are many beamlines involved in all this work, and I'm not taking credit for any of them. I'm just reminding you that we have, a host of scientists here who can answer your question. Basically, any kind of experiment that you might want to do through our open user program, these are the folks that you'd want to talk to, and their email contacts and phone contacts are there. So please reach out to them if you want to do some experiments at Chess. And next. Okay, and another thing that I'd like to point out while I have people's attention, we will be once again running the High Energy X-ray Techniques School in May. There are still a couple of weeks left to register. So this is an open school. It's targeted at students, postdocs, early career researchers, or researchers who are not experts in synchrotron techniques. And you can register if you want to come and hear lectures by our staff scientists and experts, and also perform some hands-on training at the beamlines. And so that's a free summer school or spring school that we run. It's open to everyone, but there is limited attendance, at least in person and for the hands-on training. So if you're interested, please jump on there and register today. All right, so I think this is my last slide, but keep up the great work. And also, when we report all of your wonderful work and your impact, we can do that because people remember to acknowledge the funding awards that support this place. So please do remember to do that. So you can find all of this on our website. But when you publish your beautiful results from CHESS, please make sure that you acknowledge the folks that funded it to make it possible, and the preferred wording is there. Okay, I think that's it for me.
All right, I think I'm next.
Yes.
Hello, everybody. Thanks for joining us. Yeah, why don't we go to the next slide? I'm here to talk about Material Solutions Network at CHESS. This is my sort of standard intro just to orient you. MS&C formally comprises two beamlines, FMB and SMB, with different characteristics. If you're here, you probably are either familiar with these already or know how to find out more if you want. So maybe the next slide. I won't dwell on these too much. Like I said, formally we're two beamlines, but the real magic and the thing that we care most about is our team. If you have used either FMB or SMB, you already know that a lot of everything we accomplish really boils down to the staff we have. We have staff scientists, we have student involvement, we have now 3 visiting scientists that participate in almost every, at least between them, almost every experiment and provide a good chunk of the support that we provide users. Matt Miller is the principal investigator here in MAE, and Paul and Hilmar are our counterparts at AFRL. Paul is our program manager, and Hilmar is the FMB lead. And the others here, Joe, especially Joe, Kira, and Rolf. So I want to start by acknowledging all of them and emphasizing how important they are and thanking them for everything they do. Next slide, please. The other thing I kind of never refrain from pointing out is that MS&C is a little bit different in this manner, in that the access mode is different. So it looks similar. People submit proposals, the proposals are reviewed, and then allocation and scheduling happens after that. The big difference is that the review is conducted pretty strictly by AFRL and MS&C. And that was an interesting experiment at the time that MS&C began. It's turned out to have many benefits and resulted in a lot of sort of interesting lessons, including what that permits us to do, especially in the nature of development. So that's been really successful, but of course, it's a difference. And if you have questions about that, you're very encouraged to reach out to me or any of the people I just showed on the previous screen about how that works. Next slide, please. So I couldn't resist talking a bit about using this forum to just talk a bit about some of that development that we do, in part because of this particular kind of support we have from AFRL, although all beamlines are continually developing. This last December and January, thanks primarily to Joe Crum, at FMB, we just did a host of small upgrades that all add up to, if nothing else, a far better experience for the staff, scientists, but for sure for users too. So that's an aerial view. And the next several slides I'm going to go through very quickly, but walk down that basically between December and January, we pretty much modified every component from beginning to end of this beamline. So there's 2 split ion chambers at the beginning that allows feedback on the beam position that translates to better stability of intensity on the sample. Next slide. We made a small but important change to the way that the upstream flight path optics are held. So the upper, it's a busy slide if you don't already know it, but the upper track holds our lenses for microbeam, the lower for bulk beam. And we always, that already existed before, but changes that Joe made to how those systems are held means that we can move back and forth very seamlessly. That used to not be the case. So that really reduced changeover time from microbeam to bulk beam by about a factor of 10. Next slide, please. We've thought about this for a while, and we've had different abortive attempts to add something like this snout that you see here. There's a 3D printed, vacuum compatible, basically air scattering block or part of the flight path that has two purposes. It brings vacuum all the way up almost to the sample. That reduces the background in SACs, but especially it reduces the background in the wide angle scattering. And we implemented that in order to do single fiber diffraction with fibers down to 5 or 10 nanometers, microns that is, in diameter. Next slide. And then we kind of upgraded the rail system for the downstream flight path too, which again, just really improves ease of use, especially for the scientists. All right, next slide. So moving on to SMB, we've talked about these, some of the features, the hardware features at SMB that really make it unique. And I think we can really, without too many caveats, say that SMB has world-leading capability that we offer to our users. In the one case that is most obviously symbolized by this Dectris Cadtel Eiger 16M detector. It's people are quite envious of this detector, and it's really allowed already huge improvement in the data quality for monochromatic beam work. It's been used both at 1A3 and 3A, and so we have this great technology, but we definitely like to share it with our CHEX partners over at 3A. And it's also led to a lot of interesting technique development, which is ongoing and that you will certainly hear about in the next several months. And then for white beam mode, we have this other detector that I'm not going to go into in detail. But if you haven't heard about it and want to hear more, please seek out me or any of our scientists. Next slide. So a lot of the work in the last year or so, or maybe two, has been basically making use of these technologies, finding more efficient ways to make use of these technologies, including most recently the Kugo robot people have heard about before. It's kind of coming into its own. Maybe we should have a coming of age party sometime soon. We've been working with Viridin Evolution to work on the controls, and they've had extraordinary success, especially in the last couple cycles, basically getting to the point where we can use this pretty routinely for operations. I don't want to promise that. I didn't talk to Kelly exactly about how to word that boast, but I know the progress has been pretty extraordinary. If you go to the next slide, you can sort of see an example of the robot holding a sort of a test sample, but there's a little bit of a blue laser line there. And so part of the commissioning of this robot has been understanding how to characterize its positional accuracy and validate that for particular experiments. So that's been a very sophisticated effort, and it's again involved pretty amazing contributions and sustained effort by Viridin Evolution. So we're really grateful for that and really excited about this capability. Next slide. Oh, and this is an example of one representation of one of the things that they've done is hopefully conveys the power of some of the software they're providing us, where you basically can profile a particular sample. These often can be have very arbitrary shapes. And then because data acquisition can be quite time consuming, what we really need is a way to efficiently plan where we're going to take measurements. So this is a tool that they've created for that purpose, and it really takes information from a lot of different sources, especially that laser that I just mentioned, but a lot of other sources, and allows the output from this program to be a series of points at which data is obtained. So anyway, we're really excited about that, and that's progressed the program quite significantly. Next slide. We're always eager to do more though, and I may have shown this before, but the plans for upgrading the 1A3 source are continuing to gel, and we're looking forward to installing one of two different wigglers. We're sort of still working out the details about which one will go in, but there's a prototype compact wiggler that would already be a huge benefit to the flux available at 1A3. There is an outside chance, maybe it's less outside than it was a week ago, that we might actually be able to install the full-length 1.5 meter wiggler, potentially not at its design ultimate gap. So it would be a sort of a stepwise upgrade. But in any case, one way or the other, we're very much looking forward to a pretty substantial upgrade in the flux available at 1A3 starting fall of 27. And I wanted to, Sasha's picture is there, but I want to acknowledge his substantial creative development work in developing these insertion devices. All right, next slide. So there's lots of different ways to measure impact. One of my favorites right now is that I was able to go to the sort of a 4,000 or 5,000 person meeting. It happens every year. It's called the Metallurgical Society. Never been before, but it's an enormous meeting. This was a couple of weeks ago, and the impact that I observed was that all the people you see are chess people, basically all who were presenting there at TMS. So our presence was quite significant, and it was extraordinary to be at a conference where like a domain specific conference where synchrotron content was all over the place, and that was pretty fun. Even if people weren't using synchrotrons for their work, it seemed like nobody who was unaware of the presence of synchrotrons, its utility or significance, and that's in large part because of the work that these people and others have been engaging in for especially the last decade. So that was fun. And we have a workshop coming up next week to sort of extend that impact further. This is a bit special in terms of the topics that we're specifically going into. I guess that's Chris's way of moving me along. So if you are interested in that and haven't heard about it, feel free to reach out. Most importantly, Chris, you're killing me. One slide up, please.
Sorry. All good.
Well, just pretend I had a really smooth execution of the next slide. Chris, can you go to the next one, please? So, as of last November, we are thrilled to have been able to hire Sven, who was previously our postdoc, into the staff scientist role. And he's already been succeeding to an amazing extent. We're really grateful that he came on board. And again, most people may know that, but for anybody joining from not inside our lab, you may not know. And we thank him for joining and congratulate him on this step. And then last but definitely not least, we have one other thing to celebrate, which is the newest future scientist or user. Kelly and Nino welcomed their son Jack into the world, I think November 28th, and they're clearly training him quickly. The first thing you have to learn is diffraction. Everybody knows that. So we're thrilled that Kelly's giving her a quick start, and look forward to seeing more of Jack in the years to come. Thanks, everybody.
Thank you, Arthur, and apologies for the technical difficulties. And from here, we'll turn it over to Ernie, who's going to give us an update on the XLEAP project.
Yeah, let's keep going. Slides forward, please. Forward. Thanks, Chris. So I'm going to I don't have to rush. I see we get a lot of time. I can kill 29 whole minutes, but I'm not going to. But I used this slide at the last town hall, which I think was 2 years ago, just showing you the new building. So in the brownish color is the layout of the Wilson West. At the time, we were calling it New Experimental Hall, but it now has the name Wilson West. You can see the octagonal hutch, which is the very large hutch to house the end station that Jacob was talking about in his talk. But both north and south of the HMF beamline, there's room on the floor for more X-ray beam lines. And as of 23, we proposed building a beamline for plant sciences, and that's what we call XLEAP. Later on, I'll show you spell out the acronym. But I'm going to just show you some pictures. Things have moved very quickly. We actually moved into Wilson West only at the start of 2024. And we've already filled it up 3/4, I would say. But the beamline, of course, has an undulated straight section coming down from the right from the accelerated tunnel. It has a beamline front end. Both of those things will be installed this summer. And then I'll show you some pictures. Just last week, we installed the heat-loaded optics in the cave. And the end station, I'm sorry, the hutch will be filled out later this year. But yes, we can go to the next slide. So this is where we were in December 23. This was Dragana Usic and her team doing surveying. Some of you can see, maybe if you look carefully behind them, there's a blue masking tape on the floor. That was our initial layout of the XLEAP beamline. But next slide will show you that it didn't take long before we had the HMF hutch being built. So this was already February. So this is only 2 months into having certificate of occupancy. And I just wanted to point out that in this photo, the two gentlemen are on the roof of the what we call Cave 2. They're laying down sheets of 1/8 inch lead to produce a radiation enclosure, of course. I just want you to notice that because I'm going to come back to that theme in a few more slides for XLEAP. Chris, you can move that on. So here it is. Oh, it wasn't even a few more slides. It's this slide. So now on the right here, you're looking at the XLEAP cave in the foreground and the hutch further downstream. And you see the contractors are actually hoisting, well, our staff are actually running the crane, bringing some lead sheet up. The cave needs a whole inch of lead, so they actually rolled out 8 sheets of 1/8 of an inch lead, and the hutch has only 1/2 inch of lead, so they only need 4 sheets. But this was quite our staff had to actually teach the contractors how to create a radiation enclosure. They really hadn't done much like this except for HMF. So this is now the Haight Cave hutch in January of 26. And if you go to the next slide, Chris, you can see that the week before, actually the last week of March, we took delivery of a whole bunch of crates, 9 crates coming from United Kingdom. And what's inside, of course, I'm going to not surprise you. It's the X-ray, it's the heat-loaded optics for the XLEAP beamline. And so if you go to the next slide, you'll see what came out of those crates or what was inside those crates. It hasn't yet come off the crates. In the foreground is a double crystal silicon monochromator. And these are ultra high vacuum. So what you see, the tape you see on the outside of the chamber is for bake out, for heating the chambers. In the farther away from us is a long rectangular tank, and that holds a double multi-layer monochromator. So that uses synthetic multi-layer mirrors to do the diffraction. And if you go to the next picture, you can see, I don't know if you can see it, maybe not on the people's faces, but my camera was probably shaking. So, we were nervous about picking up and moving these things into place, but our rigging crew and engineering staff and technical staff did a great job picking these things up. I didn't mention, maybe you can tell looking at it, for stability purposes, these X-ray optics are built on top of multi-ton granite blocks. And so it might be more easy to see in the next few slides, but Chris, you can go to the next one. This is the multi-layer now being rolled into the cave. So you see people inside the cave door and people beside the cave door, making sure that it doesn't scrape. And then you see in the closest to us, you see Ed Forster on a forklift, and he's pushing it as it rolls across the floor. Some of you are really into these things will notice that what we've done is we've taken apart part of the Sector 5 HMF beamline. I don't know if you see it, Chris. It's a test for you as well. But there's a horizontal black pipes that have been removed there so that we could, yeah, that's it, Chris, yep. So that we can roll the heavy optics and tall optics into the XLEAP cave. The next slide will actually, I That's a picture inside the cave. And so the closest to me, well, further away in yellow shirt is John Kopsa. He's putting lead to seal up the hole that'll go to the accelerator tunnel. And then coming downstream, you see the multi-layer model, the rectangular box is there. And then closest to us is the round cryo silicon, double silicon monochromator. So these are all in the cave. If you look around the cave, I'll stay here a minute, you see it's got a lot of lead shielding. It's got a lot of steel holding up the roof because it's got a whole inch of lead on it, many tons. You can see that there are lights installed, but by the way, the paint is still fresh. It smells like fresh paint when you're in the cave. It's only a couple of weeks old now. And you see a cable tray that's all empty. That has to be filled with instrumentation and wires and networking. That's all to come over the course of this year. And I thought I would end with two advertisements. This is Luisa Smieska's Beamline. She's the lead scientist. She's created a website where you can all go from the CHESS homepage. You can get there and learn, for instance, that XLEAP stands for X-Rays for Life, Environmental, Agriculture, and Plant Sciences. You can learn about the capabilities of the Beamline. And there's also some prototype experiments that are even going on now using other CHESS Beamlines. So you could contact Luisa if you're interested in learning more about XLEAP. And the next slide is an advertisement for a workshop that she and Elena Vedemaniak are planning for this summer to teach you about synchrotron X-rays for studying metals in plant soils and environmental systems. So with that, I will take questions just like all others.
Yes, thank you, everybody. Thanks, everybody, for the presentations, and thank you to our audience for the time. We have plenty of time, so if there are any questions for any of our directors, any of the topics that we've covered today, please feel free to let us know in the chat, or please feel free to speak up here. All right. We'll give it a minute or so, but as always, everybody's contact is on our website, on the CHESS website. Please feel free to reach out to anybody who was speaking here today, any of our Beamline scientists. We are all available for questions. The CHESS user office is always available for questions regarding proposal submissions, BeamPass issues, anything with your upcoming experiments for the spring run. Please do not hesitate to reach out to any one of us at any point, and we are always happy to assist our users and our user base as a whole. Like I said, this recording will be shared on our website, and along with some supplemental information with the topics that were covered today. So yes, please look out for that. And yeah, thank you very much, everybody, for joining, taking the time. And we very much look forward to seeing you on the next one. And if nobody else has anything to add, I'll bid everybody adieu.
Thank you, everybody.
All right. Thanks, everybody.
Yeah, thanks, Chris.
Thank you.